In this video, we are going to talk about acids and bases. So this is going to be just a quick introduction to acids and bases. We will spend more time in the spring talking about them in way more detail. So some things that we need to know about acids is acids will ionize to produce the hydrogen ion in solution. So it's got to be something with connected to a polyatomic ion or a polar enough molecule that the hydrogen ion dissociates, or the hydronium ion. So you may remember from reagents that the hydrogen ion is actually very reactive and will attach to a water molecule and then produce the hydronium ion. So it's really more accurate to say that there's hydronium ions in solution because that's how they actually exist. But a lot of times we just shortcut it with the H plus ion. Plus, it's also really obvious if you look at HCl, that it's going to ionize to make the hydrogen ion, which then would turn into the hydronium ion. So basically, you need to know that either one of those represent an acid. There's only 7 strong acids, and this was in one of our previous videos. You do need to memorize these. So we have HCl, hydrochloric acid, HBr, hydrobromic acid, HI, hydroiodic acid. So HF is not on this list. That is a weak acid because it does not ionize fully because there's a stronger attraction between the hydrogen and the fluorine. Then we have nitric acid, sulfuric acid, chloric, and perchloric acid. So out of the chlorate series, HClO4, HClO3. The other ones are not on the strong acid list, therefore they would be weak acids. So generally speaking, when we have more oxygen atoms in the polyatomic ion, it's stronger. So that's why chloric and perchloric made the list of 7 strong ones, and chlorus or hypochlorous acid did not. All right, our bases ionize to produce the hydroxide ion. And then an excess of hydroxide ions, that's what produces the basic properties. We talked about how the group 1 and heavy group 2 metals make the B on the periodic table, and that makes our strong bases. So all of the group 1s, those would be the alkali metals, so all of the group 1 metals, and then the heavier group 2, so calcium, strontium, barium. So we have 8 strong bases total. All right, the Arrhenius theory of acids and bases talks about acids ionize to produce the hydrogen ion or hydronium ion, and bases ionize to produce the hydroxide ion. There's also an alternate theory of acids and bases called the Bronsted-Lowry theory, and this is just a different way of looking at it. It allows a few more things to be classified as an acid or a base. So acids are proton or H plus donors, so they ionize to produce the hydrogen ions, they release the hydrogen ions, and bases are proton or H plus acceptors. So if we take a look at this here, NH3 is turning into NH4 plus. We call NH3 and NH4 plus a conjugate acid-base pair. So it's the 2 things that we hook together. So they are the conjugate acid-base pair. The other conjugate acid-base pair in this reaction would be water, and that's not supposed to be chloride, that's supposed to be the hydroxide ion. So water and the hydroxide ions, they only differ by an H plus. So that would also be a conjugate acid base pair. All right, so NH3 is turning into NH4. It is doing that by gaining an H plus, so NH3 is acting as the base because it is gaining or accepting the hydrogen ion. Water is acting as the acid because it is losing the H plus ion. In Regents, we had the saying that people who do acid are losers, so acids lose the hydrogen ions, which would be consistent with acids ionizing to produce the hydrogen ion. All right, a neutralization reaction combines an acid plus a base to make water and an ionic salt. The pH will head towards neutral, but we will learn later on in the year that when we have a neutralization reaction, sometimes the pH is not perfectly 7, depending on the salt that you are producing. But all we need to know about now is neutralization reaction is an acid plus a base makes an ionic salt and water. So here we have acetic acid plus sodium hydroxide makes sodium acetate and water. All right, so now we have 2 examples of a neutralization reaction. So we have to write the balanced molecular equation for the reaction of hydrochloric acid and sodium hydroxide. So hydrochloric acid would be HCl. So again, we have to have our formulas memorized. Sodium hydroxide, NaOH. We have an acid plus a base, so that is always going to make water. And an ionic salt, that would be the NaCl. Now, in order to make the water, it's the hydrogen ion from the acid plus the hydroxide ion from the base make the water, and then the leftover cation and anion will make our ionic salt. All right, we are going to next do our net ionic reaction. So net ionic reaction, you break apart strong acids, strong base, soluble ionic compounds. So HCl, certainly a strong acid. So H plus, Cl minus. So now we're writing it as they actually would exist in solution. So the NaOH, that's a strong base, so that's going to ionize, so it's actually going to exist as sodium and hydroxide ions. HCl is going to actually exist as hydrogen and chloride ions. Water stays together because most of the water molecules are not going to self-ionize, they're going to stay together. Plus, again, you only break apart your 7 strong acids, 8 strong bases, soluble ionic compounds. All right, then we would also break apart Na and Cl into its ions. Then we need to cancel our spectator ions, so Na and Cl. Then we finish with what is left. So we have the hydrogen ion plus the hydroxide ion combines to make water. So that would be the net ionic reaction for the neutralization. And this would actually be the net ionic reaction for the neutralization of any strong acid and strong base. Weak acids and bases would look different, but on a strong acid and strong base, this is what we would end up with. All right, so now we are going to do this again, but this time we are going to react acetic acid and they said that that would be aqueous, so we'll include that, and barium hydroxide, and that would also be aqueous. Oops, barium hydroxide should have the 2 there. Okay, so we have a neutralization reaction because we had an acid plus a base. So we have to make water. The water comes from the hydrogen ions from the acid, the hydroxide ions from the base. Then We have the leftover ions as a salt. Barium has a +2 charge. Acetate has a -1 charge. So it's going to be 1 barium ion and 2 acetate ions. That is going to be aqueous because acetates are one of our always soluble ions, no exceptions. All right, then we need to balance this. So we would need a 2 in front of the acetic acid and a 2 in front of the water. Next thing we do is start working on our net ionic reaction. So we have to think about what we split apart, what we keep whole. We split apart our 7 strong acids, 8 strong bases, soluble ionic compounds. Acetic acid is not one of our 7 strong acids, so we keep acetic acid together because acetic acid only ionizes slightly, not enough for us to be showing that in a net ionic reaction, because in a net ionic, you're talking about what's happening to the majority of the particles, and the majority of the particles of acetic acid stay together. Barium hydroxide is one of our 8 strong bases, so that would ionize. Water is not one of our 7 strong acids. It is not one of our 8 strong bases. It is not a soluble ionic compound, so water stays together. Barium acetate is soluble because acetates are always soluble. So we will show that being ionized. All right, now we need to cancel out any of our spectator ions. So that would be just barium. And then we are going to rewrite our net ionic reaction. So we have 2 moles of acetic acid plus 2 moles of the hydroxide ion. That produces 2 moles of water and 2 moles of the acetate ion. Now, because these all had 2's, I will reduce that down to 1's. Now, in the previous slide, we had a net ionic for a strong acid and strong base. This is a net ionic for a weak acid with a strong base. And notice these look different. So when you have a weak acid, the net ionic equation is going to look different because the weak acid does not ionize, or does not ionize to a large extent. All right, we have another example. So now we are going to react carbonic acid with potassium hydroxide. So we are an acid plus a base, so we have to make water and an ionic salt. So our ionic salt would be K2CO3 because potassium is +1, carbonate is -2. For balancing, we're going to need a 2 in front of the KOH and a 2 in front of water. All right, then we need to write the net ionic reaction. So we have to think about what we split apart. We do not split apart carbonic acid because it is not one of our 7 strong acids. We do split apart the KOH because that is one of our 8 strong bases, so it will fully ionize in solution. We do not split apart water because it does not fully ionize in solution. We do split apart the potassium carbonate because that is a soluble ionic compound. Group 1 ions are always soluble in water. All right, then we cancel out any of our spectator ions and then rewrite what is left over. So we have the carbonic acid plus 2 moles of hydroxide. Combine to make 2 moles of water. And the carbonate ion. So that would be the net ionic reaction for that. All right, last thing for this video, when the carbonate ion or bicarbonate ion reacts with an acid, it produces salt and water like normal, and then also carbon dioxide gas. So the way that we are going to remember this, we are going to remember the volcano that you probably made at some point in grade school. So that is baking soda plus vinegar. So baking soda is sodium bicarbonate. So you have the HCO3 ion in there. Vinegar is an acid that produces water, a salt,